Hello everybody! I am going to do a demo of a DC blocker today, and I want to explain something about DC offset on the power line. A lot of people think DC offset on the power line is like a noise. Perhaps if you look at it in the mathematical point of view, it is a noise because it's an anomaly from the sine wave being at the 0 point. Now the 0 point, let's say the 0 point is a flat line. A perfect sine wave is up and down. Riding on that flat line, top and bottom section are perfectly equal. That's the ideal sine wave that has no DC offset. I don't see DC offset as a noise. I see DC offset as a phenomenon or condition that caused by outside reasons. I don't know. I can't come up with the word right now, but I have a halogen light that actually have a half bright setting, which use a half wave bridge rectifier that can put DC offset on the AC line to demo the noise caused by the DC offset from the transformer. The reason I don't see DC offset as a noise is because you just cannot use any filter to clean the DC offset. More or less you have to block the DC offset from keeping it coming in. Well, you can argue the noise is the same thing, but the way to block the DC offset is not the same way to actually filter the high frequency noise. There's only one power line filter or conditioner that can block DC offset rather than a dedicated DC blocker is the transformer based power line conditioner. And the transformer based power line conditioner block the DC offset from the power line so the power amp transformer doesn't growl. It's not a hum, it's a growl. I will show you, you can actually hear it. But the transformer itself inside the power line conditioner growl just as bad. The bigger the transformer, the louder it growls. I call it growls, not hum. Now those are the wording are important when you're troubleshooting, especially over the phone or email or internet. It's rather disappointing that people don't know how to use the word anymore, and the writing is getting really bad, and even English is not my first language. I can, well, at least I try to write better. So hum, buzz, and growls are all three different things. And within the three different things, they have a different kind of buzzing. The buzzing has the most different variations, and depends on what is buzzing, how it's buzzing. It actually tells the troubleshooter where to look for the problem. So if you are actually trying to have somebody to help you solve problem over the phone or the internet, those wordings are very, very important. Where it comes from, how it sounds. One thing that a lot of us trying to do is using the cell phone to record the noise. The cell phone bandwidth are very narrow. They're designed for conversation. They're not designed for music. They're not designed for noise. So low-level hum is very difficult to pick up for the cell phone. I have tested this lapel mic and pick up the growl from the transformer, but I'm hoping YouTube are not going to cut out that bass. I don't think YouTube would, because music have lower bass than that growling, because that growling is a harmonics of 60 Hertz. It's not pure 60 Hertz, so you will hear the growling. So this is a DC blocker that I made. It's a product. It's very strong. You can actually drop it from 3 foot on floor. It won't hurt anything. It will hurt your foot. It won't hurt it. So let's show this. I am going to turn this transformer on without any DC offset as little as possible. I know my shop is fairly clean because I have my own transformer on the pole because I live in the farm. So that's why the power is very clean as long as I turn off everything that I have. I still have some dimmer, but the dimmer are not the horrible triad type. Those things you can't help it. It just replace it. And I know so many people use them because they are cheap, they are effective, but they are not designed for sound system or even TV system, video system. It's not designed for that. They are purely designed for visual, look, light. So if you are building a sound room, audio visual room, you have to find people that knows how to do it. It's not just a typical lighting. You will have to prepare to pay more and get the proper lighting that doesn't generate noise. So on our side, we're trying to clean up all the noise as much as possible. But on the other side, which is a bigger world, they are generating noise, more noise every day. Wi-Fi noise is another thing, but that's not today's topic. So okay, I'm going to turn this transformer on. Right now, it's not on, but when you see this blue LED light turn on, it is on. And I'm going to put the mic on the transformer. You can barely hear it. You can still hear the transformer growl as a normal condition. I'm going to put it on. When I turn on, you will hear the inrush current growl. Let me see. Turn it on now. I can hear the hum, but no growling. I'm going to keep my mouth shut and for a few seconds and see you can hear the hum. The background noise in this room is actually just as loud or louder than the transformer hum right now. I can actually hear the clock ticking, but the transformer hum is a soft, smooth 60 Hz hum, not very far away. It's a solid hum, but it's not very loud. Now I am going to turn this halogen light half on. You can still see the blue light is on, which means the transformer is on. I'm going to turn on half bright. That's the solid growl. That's why I call growling. That's DC offset on the transformer. Turn this on full bright. Back to normal. So one of the biggest problem of DC offset on the power line is the half-wave rectifier. Basically, half-wave rectifier drawing power from one part of the sine wave, either the top part or the bottom part, but not both. But if you join both power from both parts, you are end up drawing equally low. So the transformer itself is still seeing a sine wave on the zero line. But if you join just one part, the top or the bottom, the sine wave being pulled unequally. So therefore, one side is going to be the one side going to pull more, and the sine wave going to be pushed up or down, depends on which side of the sine wave, which part of the sine wave you're going to draw more or less. So the higher power the rectifier, meaning the more one part of the sine wave being drawn more, the farther the DC offset is. So in a lot of cases, a small LED also use a half-wave rectifier because it's save money. You compare with one dial as a half-wave rectifier to 4 dials as a full-range bridge rectifier. A full-range bridge rectifier will not dump DC offset or generate DC offset on the power line, but a half-wave one dial rectifier will. We'll say that's like, what's the different cost in 4 dials and 1 dial? To me, it's not. But for a bigger company that have lots of employees to feed and a lot of overhead to spend, and that make a big difference. Because every single piece of component, they're selling thousands of them. If you're saving 3 dials per unit, they're saving thousands of dollars or tens of thousands of dollars per model. And that's a whole one person salary for a whole year. That's a big difference. So you gotta look at manufacturing point of view. When you do a mass production, that you gotta look at every single dial, every single screw. But when I'm doing my one person custom made, okay, well, I think I can do better on that one. Then put a couple more screws in, it's no big deal. But when you're doing mass production, it's like hundreds or thousands of them. You changing one thing is a big deal. So they will have to design something and it just fix. It just stay. You can't improve just one product out of 10 or one product out of 100. So they have to cut costs as much as possible. Whatever thing is like, even a screw, even a single piece of 2-cent screw makes a difference for them. Anyway, so what are you going to do if you have DC offset? You can always buy a DC blocker. When I first building this DC blocker 20 years ago, not that many companies are building it, but now almost everybody have one. But a lot of DC blockers, they are rated as 6 amps. I rate mine as 15 amps because you can put it in power line. And the capacitance inside, which is basically a 2 capacitor back to back, make it bipolar, and it can handle as much as 15 amps. And I have actually tested with a shorts. It blew the 15 amp fuse. It didn't hurt the DC blocker. So I'm gonna put this in between the power bar and the transformer and do the same thing. Turn it on without the light. Turn it on half bright and full bright. Turn it off first. This is going to the DC blocker. Wire going back up to the transformer. Turn it on. Is this on? I am going to turn it back off first. Okay, it's off now. I'm going to turn it on. You will see the blue light. Don't fall off there. The DC blocker is in line right now. And you see this light going to turn on. This is right now it's off. With the DC blocker, it's actually quieter. Even with the halogen light is not on. But let me turn it on now. I will keep my mouth shut. It is on. I believe you hear the inrush growling a little bit, and then it settled down. I heard it. I don't know the mic picked it up, but when it turned on, it growled like oop, 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 and then it settled down. And then once it settled down, it's very quiet. I am going to turn it half bright of the halogen light. So did you hear the initial growl and then settle down? Full bright. The switch, it gets you the initial growl, but it settled down. I'm going to turn off and half bright again. So this is how quiet with a DC blocker, and this is a 2000 watt transformer, and I am going to plug it back in for you just to let you refresh how noisy, how growly it is when at half bright. This is half bright. DC offset on the power line. Full bright. Not as bad. It's off. Turn off the transformer. Okay, so that's my demo for the DC blocker and my brief explanation of how DC offset is working. And just remember, if you have a DC offset, if you have transformer growling and a DC offset, no filter out there will cure the problem. You have to get a specific DC blocker. If anybody claims it's a DC blocker, it should fix the problem. And just don't buy any parallel device, especially parallel device. And no parallel device will clear DC offset. If anybody tell you the dangle and dongle devices from the power line, plug here and plug there, can cure DC offset, they're lying. I do understand there's a lot of people saying that, and I give them the benefit of a doubt. They are not all lying. Some of them are just ignorant. Some of them are naive, ignorant, and just don't know what they're saying. And I see a lot of salespeople online in store are doing that because they're poorly trained. In many cases, I bring the management. They're poorly trained, and some of them are just don't know what they're saying. And in the worst case, some of them are just lying. So I said that 3 times. Did I say 3 times lying or not? Okay, lying. So until then, stay safe. If you hear the growl, it's DC offset, it's not noise, so don't buy filter to clean them up. But stay safe. Bye! I gotta go around and turn off the camera.